Manufacturer తర్వాత ఏంటంటే ఫస్ట్ బస్ చెప్పింది Good morning, all.
Okay, my voice is audible.
Yes, sir.
Okay, in the last session, I will discuss about searching algorithms, linear search and binary search. In this session, I can start sortings. The sorting means rearrange the elements. The elements can be assigning in ascending order, descending order. The array they containing some set of elements. All elements can be assigning in a ascending order or descending order. That means increasing order or decreasing order. For example, I can take some set of elements. So 2, 1, 5, 3, 2. The elements are taken in randomly, not a specific order. So in that time, the elements can be assigning in increasing order. So the finally is replaced 1, 2, 2, 3, 5. So again, the same set of elements can be placed in decreasing order. So that means decreasing order means the largest element can be placed in first, the smallest element can be placed in last. So this is called as sorting. So you can implement sorting. They containing plenty of algorithms. In this session, you can see the one of the algorithm is bubble bubble sort algorithm. So the bubble sort algorithm, the particular elements can be arranging in increasing order or decreasing order. So every time you can select two elements. So the pair of elements every time can select the pair of elements. So in the time to check the particular elements can be in ascending order. So you can left the particular element, then go for next pair. So you can complete the process until you can reach all the elements. Every time you can select two elements. So the two elements are in specific order. Again, you can take another two elements. You can continue the process. That is the logic for bubble sort. You can see the example. So I can take five elements, 2, 1, 5, 3, 2. So finally, the all five elements can be arranging in a increasing order. The first I can select first two elements in the given list. The first two elements are 2, 1. So you can check it. The 2, 1 is not placed in increasing order. The two elements in decreasing order. So immediately I can swap the both elements. So finally is replaced to 1, 2. So after that again I can select two elements. The two elements is 2 and 5. The 2 and 5 are in increasing order. Again I can left the two elements. Again you can select another two elements. The two elements are 5 and 3. So in that time again I can check it. The two elements are again in decreasing order. Again swap. And the 5 element can be passed into element 3 position. The element 3 can be passed into element 5 position. You can swap the both elements. Finally, I can check it. And 5 and 2. So again is in decreasing order. Again you can swap the both elements. Finally, the 2 is replaced as element 5 position. The element 5 is replaced as 2 position. So you can complete the first pass. So the pass is the number of iterations is depending on the elements. They containing n elements. You can complete the process in n minus 1 iterations. So in that time they containing 5 elements. You can complete the process in 4 iterations. I can complete the first pass. Then again you can start the second pass. In that time also you start from initial element. The first I can check it the both two elements. So finally you can complete the first pass. The elements are 1, 2, 3, 2, 5. So again I can start the procedure. First I can select two elements. The two elements are increasing order. You can left. again you can select next two elements. First I can select 1, 2 is in increasing order. Again I can select 2, 3. So again the 2, 3 is also in increasing order. So again I can select 3, 2. The 3, 2 are in decreasing order. Immediately I can apply the swap. So I can swap the two elements. So again I can check it 3 and 5. 3 and 5 is also in increasing order. So I can complete the second pass, then go for the third pass. So in the second pass completed, the all elements can be in ascending order. So but again you can complete two passes. So again I can start the pass from 1, 2 is in increasing order. Again 2, 2 is increasing order. 2, 3 is increasing order. 3, 5. So again go for the fourth pass. So 1, 2. So again 2, 2, 2, 3, 3, 5. Finally you can complete all four passes. The given elements can be in increasing order, ascending order. So the drawback of bubble sort, for suppose in this particular problem, the two iterations is completed, the elements can be in sorted order, but you can not stop the process. So again, you can repeat the process. So again, you can note down the another important points is underlining the pair show the comparisons. For each pass, there are a size -1 comparisons. So they containing n elements, they must ensure the total number of comparisons is n-1 comparisons. So in that time, I can take another set of elements. So in these elements can be arranging in a ascending order. They must and should they having 4 iterations. So you can take 4 iterations. Finally, all the elements can be all the elements can be rearranged in a specific order. Same in the time also the all elements can be assigning in increasing order. So in that time I can take 5 elements, 5, 4, 3, 2, 1. The elements in decreasing order finally is converted into increasing order. So the first I can take the 5 elements are 5, 4, 3, 2, 1. Then you can start the process. So you can complete the bubble sort. The total number of iterations is 5. So the number of elements is 5. So the iterations is 5 minus 1, the 4 iterations. So once you can complete the 4 iterations, the all elements can be in increasing order. So I can start the process. First I can compare 5 and 4. The 5 and 4 in decreasing order. Immediately you can swap the both elements. So 4 is placed in first position, 5 is placed in second position. So again, you can take another 2 elements. The 2 elements is you can complete the first element, then you can take the 2 and 3 elements. The second element is 5, the third element is 3. So again, you can compare. The both are in decreasing order. Again, you can apply swap. So again, 5 and 2. So again, it is also in increasing order. Again, you can swap. Finally, 5 and 1. So again, is also in increasing order. Finally, the largest element, you can complete the first iteration. You can complete the first pass. The largest element can be placed in last position. Then you can start the second pass. So in the second pass is aim is the second largest element can be placed in n-1 position. So again you can start the comparison 4 and 3. So again is not in increasing order. Again you can apply the swap. So again you can take the 2 elements are 4 and 2. So again you can apply the swap because the 4 and 2 is increasing order. So again, you can apply the swap 2 4. So again 4 1. So again is in increasing order. Again, you can apply the swap 1 4. The final you can check it 4 and 5 is in increasing order. You can complete the second phase. Again, you can start the third phase. So in the third phase, aim is the third largest element can be placed in n minus 2 position. So again, you can check it 3 and 2 is in increasing order or decreasing order. So is placed in again decreasing order. The largest value can be placed in first. The smallest value can be placed in next. Immediately you can apply the swap. Again, you can take another two elements, 3 and 1. So again, is in decreasing order. Again, you can apply the swap. So compared to remaining comparisons, 3, 4, and another one is 4, 5, is in increasing order. So you can complete the third phase. Okay. So in that time, you can given by mistake you can replace 2. So the last elements are 2, 1, 3, 4, 5. Not 2. That is the 1. Again, you can start the process. So in the fourth phase, the elements are 2, 1, 3, 4, 5. So again, you can start the process. First, you can take the two elements. So every time you can take the pair of elements. So based on that reason is called as a bubble. So every time you can take two elements. Okay. So first you can take 2 and 1. So once you can apply the bubble sort, you can comparison of two elements. The two elements in increasing order. So in that time, you can place the elements in as is. Otherwise, you can swap. So once you can complete the fourth phase, first one after that you can check it 2 and 3. So is in correct way. Then again you can check it 3 and 4. So again finally 4 and 5. So finally the all 5, 4, 3, 2, 1 can be placed in increasing order is 1, 2, 3, 4, 5. So then you can check it the logic. So how to implement this concept, the bubble sort concept. So in that time initially I can take array. So in the particular array I can put it some set of elements. So after that I can rearrange the elements in increasing order. So initially I can take array A. The size is assigned to 5, including only 5 elements. So immediately I can assigning all 5 elements. So in the time I can write two statements before sorting and after sorting. Before sorting I can print all array elements. So in the time I can use for loop for I is equal to 0, I less than size, I plus plus. So every time I can print a of I. So in the time I can define the type of array is integer. So in that time I can indicate percentage %d. So before that I can define 4. That means every time you can print the relevant information of the array. After that you can assign 4 spaces. Then you can print another element. Okay. So based on that reason you can define the differentiate from one element to another element. In that time I can put it some space. So this based on that reason I can assign 4. So after that I can call a function. The function is bubble sort. So this is a function declaration. So once the cursor is entering into the function declaration, immediately is jump into the function definition. So this is the function definition, that is the exact logic to implement bubble sort. So in that time, you can read only array. So the array containing some set of elements. In the time, I can choose three variables: I, pass, temp. So the all relevant information can be stored in a temporary variable. So based on the reason, I can use one temporary variable. So in the time the pass, the number of iterations to complete the entire process. So that is depending on pass. So you can start the process. So in that time, you can use two for loops. One for loop is indicates the number of iterations. So another for loop is usually for the all elements can be placed in increasing order. So you start from pass one. So the pass can be completed in n minus one, size minus one. So based on that reason, I can assign the logic is pass less than size. So again, I start the process for I is equal to 0, I less than size minus 1, I plus plus. So once you can complete the first iteration, the largest value can be passed into the last position. Based on that reason, the I for loop can be repeated in only n minus 2 iterations. So every time first iteration is completed, in that time you can avoid the last position. Then again you start the process from the 1 to n minus 1. After that you can complete the second iteration. Again the process can be start from 1 to n minus 2. Every time you can left the one position left. Every time you can left the last position. So initially start the process. If in the time can comparison of first element and next element. Every time can take the two elements. A of 0 greater than A of I plus 1. You can satisfy the condition. Immediately you can apply the swap. Immediately you can apply swap. Otherwise, not perform any operation. Then you can move to next two elements. So A of I, A of 0 greater than A of I plus 1. So for suppose the elements are 2, 1. Okay. So the 2 greater than 1, the condition is true. So finally you can apply the swap. So finally the elements can be assigning in 1, 2. So again compare next two elements. The next two elements is 2, 1, 5. So again you can check it the two elements. So in that time A of 2. So A of 2 containing element 2, 2 greater than 5. The condition is false. So again go for the next two elements. For the next two elements 5, 1, 3. So again compared to the elements 5 and 3. Again condition is true. Again you can interchange the values 3 and 5. So again go for the next element. Next element is 5, 1, 2. So again 5 greater than 2. Again condition is true. Again you can swap. Finally the elements are 1, 2, 3, 2, 5. So you can complete the first iteration. So you can complete the pass 1. Then you can go for the pass 2. So again you can check it. In that time you can complete the second pass. The elements are 1, 2, 2, 3, 5. Okay. This is the logic to implement bubble sort. Clear? All of you. So the bubble sort algorithm is very easy to implement. Every time you can take two elements, you can compare the both elements in specific order. There is no problem. Otherwise, you can apply swap. So this is the logic. This is a very simple logic. So in that time you can read the array. So after that, every time you can take array first two elements. So you can compare the both elements is in the specific order. You can left. Otherwise, you can immediately can apply the swap. Then you can take array second element and third element. Again you can check it. Then you can take array third element and fourth element. Again you can take fourth element and fifth element and so on. So for suppose they containing n elements. So all n elements can be comparison. So in that time you can implement bubble sort. The total number of iterations can be done in n minus 1. The size minus 1 depending on the array elements. Okay. Clear? In this session, I will discuss only one sorting algorithm. The next sessions I can discuss about the remaining sorting algorithms. Every day I can possibility we can explain one or two sorting algorithms. Okay. Anyone having doubts? Hello? My voice is audible?
Yes, sir.
Yes, sir. Okay, clear. అర్థమైందండి.
Yes, sir.
So you can see the source code. Then you can implement the particular source code. You can execute the program. So in that time, I can default. I can assigning some set of elements. So you can use scan function. You can read array elements. Again, you can check it. Okay. May I leave?
Bye, sir.
Okay.